All right. Hello, everyone. My name is Dylan Mangel, Extension Pathologist at the University of Nebraska, Lincoln. And today I'm also here with Dr. Horacio Lopez Nicora from the Ohio State University. And we're going to just cover a little bit of soybean cyst nematode and what's been going on in that system, as well as give an update on the SCN coalition.
Thank you, Dylan. Like you mentioned, my name is Horacio Lopez Nicora, soybean pathologist and nematologist here at Ohio State. So to get started with the presentation today, we'll start by addressing a little bit about the biology of this animal. This is an animal, the soybean cyst nematode, that is considered the number one pathogen of soybean in North America. And we'll talk a little bit about why that is. And the way that we like to begin addressing how soybean cyst nematode causes damage is through the life cycle of this pest. So it starts with the eggs. You can see that the eggs undergo several cell division until it will end up with the nematode actually coiled inside the eggs. It will molt one time and then hatch as a second stage juvenile. This is the only infective stage of the nematode that with the aid, the use, the help of the stylet here on the head of the nematodes that I'm pointing, will create physical damage and penetrate the soybean roots. You can see that we're staining these roots and we can see the nematodes that are physically opening entrance and penetrating the roots. They will migrate to the vascular cylinder and will start probing cells. Those soybeans, if susceptible, they will engage in an interaction with the nematode and will start feeding the nematode. Those cells will modify to become now feeding sites. The name of these feeding sites is syncytium, and they will start feeding the nematode for the rest of its life. The nematode now will become sedentary, will not move, but will continue developing, as you can see here, through the other multiple stages of the nematode. The nematodes have 4 juvenile stages until they reach adulthood. The male, as you can see here, will leave the root. It will regain that worm-like vermiform condition. It will regain motility and it will leave the root to find fertilized females, and these females that are attached to the roots, they continue and they will remain being sedentary. They will lay on average 250 eggs. And then eventually the females will fill up with eggs, they will die, become cysts that will protect these inoculum for the next generation. Now, these can happen multiple times during the season, 3 to 6 times during the season. So you can see how easily we can start with very low levels of soybean cyst nematode and end up with above damage threshold. Now, one characteristic of this pathogen is that it really takes control of the plant machinery, and most of the time, in most fields of the northern central region, significant yield reduction will take place with no above ground visible symptoms. And that's one of the reasons that soybean cyst nematode remains the most economically damaging pathogen of soybean in North America. We just cannot see that we're losing significant amount of yield based on what the plant looks above ground. We pull those roots, the roots won't lie. We will be able to see the nematode. We will be actually able to see the nematode with our naked eye. Those are the females attached to the root. They're very tiny compared to the nodules, something that we shouldn't mistaken with. The nodules are that symbiotic interaction with bacterium that will fix nitrogen, and we want that. The soybean cyst nematode females attached to the root are way, way smaller than that. In cases when we have stressors, additional stressors in the environment, we may see symptoms such as stunted plants, fluorosis. If there are nutrient deficiency, those may be more visible and enhanced. Let's say potassium deficiency. With the presence of soybean cyst nematode, we may see more of that marginal chlorosis. There are also interactions with other pathogens. Let's say we have a field with the presence of the fungus that causes SDS. And in the presence of the nematodes, we may see more SDS than if we didn't have that, both of those pathogens together. So great opportunity to sample fields where we're seeing more of these type of stressors showing up. But most of the time, unfortunately, this is the nightmare we have to deal with in a field infested with soybean cyst nematode. What I'm showing here is a susceptible cultivar next to a resistant cultivar that clearly shows absolutely no difference in terms of symptomology. However, we go and we harvest that susceptible cultivar to the nematode, and we will see significant yield reduction compared to a resistant one. And we're talking on average 30% yield reduction. That's a lot. Here, clearly, we can see that with stressors conditions, we can tell a susceptible reaction versus a resistant cultivar. So resistant cultivar, susceptible cultivar in highly infested field, showing that difference. Again, significant yield reduction in most cases with no visible symptoms. And the nematode is present in most of our soybean producing counties. So here we're showing a map where red is the places where the nematode has been detected previously. Blue is, as of this publication, new counties that reported where previously SCN was not detected. And unfortunately, the nematode also continued to evolve and adapt and gain the ability to reproduce on sources of resistance. So, Dylan, what's going on in Nebraska with soybean cyst nematode?
Yeah, so we're sort of on the western front of nematode expansion. It entered our state in 1986 was when we first found it, and it's just slowly continued to spread west. But we talked about it spreading on that previous map and showed that it's in a lot of the production regions, but it's important to show that just because it's there, it's not really represented at high levels in those fields. So in the northwestern part, or northeastern part of the state, we have the highest concentrations or the highest rates of positive samples coming into our testing program. But even then, it's only 50 to 60% in a few counties. And most of our state, we're looking at below 30 or below 20% positive fields. So there's a lot of opportunity for this nematode to continue to spread and cause more yield loss than it has in the past.
And this is one way to show our data from surveys that we conduct, growers that submit samples that we can use this information to inform other growers. In Ohio, we do something similar. We process every year samples that we receive from growers, and we can see that here, this map is showing abundance of soybean cyst nematode, how many eggs per 100 cc of soil we get from those fields, right? And then we get an average for the different counties. And this is the area in Ohio where we grow soybean the most, but with expansion also to this area here. And we see that the highest numbers that we're retrieving are from places where we do have a lot of soybean production. And the nice thing of this type of surveys is that we can very early detect the presence of soybean cyst nematodes where we previously did not. And this is an example in Ohio, two counties where we did not detect soybean cyst nematode before because samples are arriving, because soybean is being grown now in these areas. We're being more vigilant and very early on detecting the presence of soybean cyst nematode. And why do I say this? Well, with more than 2,000 samples that we already processed in the lab, more than 60% of these samples are positive for soybean cyst nematode. So you see that 60% of those samples that we received tested positive for soybean cyst nematode. However, most of them are very low levels of soybean cyst nematode. So they have very low numbers of eggs per 100 cc of soil. And that's what we really want. We want to identify a field with soybean cyst nematode, but a very low level, because keeping these levels low will help us protect our yield more. Bringing fields that have above Damat threshold below Damat threshold is really hard. it will take us longer, and we will suffer yield reduction, unfortunately. So very soon, identify if a field is infested with soybean cyst nematode. Once we know we have soybean cyst nematode, it's very unlikely that we are going to eliminate soybean cyst nematode from that field. But keeping levels low, it's a great strategy, and we'll talk about how to achieve that. Now, when we look at the map of Nebraska, Ohio, and any other state, and the distribution of the nematodes across the North America, the next question is, are all these populations behaving the same? And unfortunately, the answer is no. So very soon after we discovered soybean cyst nematode in North America in the 1950s, we were able to also identify sources of resistance. And one very common source of resistance that is used and was used is PI 88788. PI 88788 was very easily introgressed in commercially available soybean and worked really well for the population of nematode we had. And we used it for over 30 years. So we use the same source of resistance over the same population of soybean cyst nematode across the country for a long period of time. This exerted a selection pressure on that population, which shifted the virulence. So a population that we could manage very well with PI 88788 was able to adapt and now reproduce at levels above 10% compared to a susceptible, which means that now there are populations that can reproduce, for example, at 80% compared to a susceptible, which means that PI 88788, it's only 20% effective. And we have a name for this. We call this female index. And it's really important for us to use this female index to understand, well, that population, it's reproducing at such level on this source of resistance that it's not effective anymore. I need to rotate. I need to switch to a different resistance source. Another one that is commercially available to growers is Peking, which can be a great option when the population is not able to reproduce on Peking. So a population that unfortunately was able to adapt and reproduce on PI 88788, but not yet on Peking, can be a great scenario where we can use Peking to reduce the population of the nematode while keeping those yield up. Dylan will talk later about the risk of using Peking recurrently. So we want to avoid that. We want to avoid using Peking recurrently, that it will shift the virulence to allow the nematode to reproduce on Peking as well. So unfortunately, like I mentioned, PI 88788, the resistance is being reduced due to the adaptation of the nematode. And then we have a great alternative that we can use in rotation of these sources of resistance, but it is a high risk if we misuse it to, again, run into the same problem that we did with PI 88788. And that brings us to the integrated management approach. So we're dealing with an animal with a pathogen, the most important pathogen of soybean, that can cause significant yield reduction with absolutely no above ground symptoms. So my soybean looks very healthy. I don't want to know if I have a problem. Well, maybe we do want to take a test and see if we have soybean cyst nematode. I understand that a healthy looking soybean field may tell us you're okay, you're doing great. Yet we're leaving below ground significant amount of yield due to this pathogen. So we recommend, as an active management, to test the field, collect a soil sample, know if you have soybean cyst nematode. If you do, how much soybean cyst nematode you have. Know your numbers. That will dictate the management strategies that you will apply in the field. Rotating to a non-host is key. The soybean cyst nematode reproduces very well on soybean, but it does not reproduce at all on corn, which is a crop that we use in rotation. So by planting corn following soybean, we may reduce significantly the levels of soybean cyst nematode and will allow us to go back to soybean with less pathogen pressure. Rotate sources of resistance is key. Even if most of them have that PI 788 in the background, I just mentioned that that's the main source of resistance. Even if that's the only variety that we can get a hold of with PI 788 as a source of resistance, still, we recommend rotating varieties. Don't train this animal to feed on the same genetic material. If we can get a hold of a different source of resistance, such as Peking, we strongly recommend rotating sources of resistance as well. And then consider a seed protectant to essentially enhance that root health. There are other organisms that can interact with a nematode. And if we keep that root system healthy, that will protect the yield against multiple pathogens.
So Horacio mentioned the importance of testing. You really don't know if this nematode is there unless you're testing your soil. But when we test soil, we take it to a lab and we separate out those nematodes and we count them. And we're going to provide growers with a count. We're going to say you have 1,500 nematode eggs per 100 cc's of soil, for example. But it's really hard to know what that means, how to interpret that, and how that's going to impact your farm. And the reason we can't just tell you the answer to that is because it often depends on your farm, what sort of soil properties you might have there. It also depends on that local nematode population. So what we've done is we've built a tool at the SCN Coalition called the SCN Profit Checker, and it uses a lot of historic data to help estimate what sort of yield loss you could anticipate if you have that egg count that you got from a soil test on your farm and with some of the soil properties in there. And it gives you a bit of an idea of what sort of yield loss you might lose. So here I'll just run a simple example of what this tool would output. In Nebraska, the median number of eggs per 100 cc of soil is 4,000. So we get a lot that are below that, a lot that are just a trace, and we have some that are quite a bit higher than that as well. But 4,000 is pretty middle of the road. That seems to be the cutoff between low and moderate when it comes to infection levels. In the case of Nebraska, we've auto-populated the SCN female index on PA 88788 at 35%. So that's something you don't need to know as a grower, but you do need to know a sand percentage and a soil pH for your field. So in the situation where we've got 20% sand and a pH of 6.5, with a female index of 35, a grower might experience something like 6.1% yield loss. Now, the problem with that level of yield loss is you might not notice it's missing if you don't have any noticeable above ground symptoms. A yield loss like that could sneak under the radar. And when you have tens of thousands of farmers all losing 6.1%, it adds up to that huge impact that the nematodes have on our soybean production. This tool is also going to let you put in your local price that you have available and give you some price information as well. But the big problem, and the reason this problem continues to get worse, is that shifting that we've seen in female index. So basically that shift in how well the nematodes are able to overcome the resistance gene. So on PI 88788, if we change that female index from 35 to 90, a number which is high, but which is also found in Ohio and Nebraska, as well as many other states in many fields, and keep all the other numbers the same, that's going to mean that that nematode is able to overcome on that resistance source much more efficiently than before, and that resistance gene is doing less to save yield. In that case, you end up with an estimated 15.5% yield loss. So this shift from one to the other is not going to happen overnight. But if you're going to continue to use an 88788 variety on your fields every time you rotate the soybean, especially the same variety, you're going to have that buildup of yield loss continue to occur until you get to a much higher level like this. So the economic impact is going to be much higher on fields like that. So that's why it becomes so important to remember to rotate resistant varieties. The populations have been evolving for many years to overcome that. But how quickly it does that is dependent on how you rotate varieties on your fields. And that goes for PI 88788, but also peaking. And ultimately, the best choice would be a multi-year rotation plan where you are rotating with a non-host crop. In this figure, it's shown on the even years. But then on the odd years, you start with, say, a PI 88788 variety. In year one and year three, you maybe choose a peaking variety if you can find a good one available that you like. And then in year five, um, use maybe a different 88788 variety. And just make sure you're not planting the same soybean variety in all three of those years of that 6-year rotation. That's going to that's going to apply that selection pressure, which will allow that population to quickly get used to those resistance sources, and you'll lose those tools as far as management on your farm in the future. So the SCN Coalition is a project that Horacio and I lead together. And the goal of this project is to raise awareness of these problems. Uh, we need to raise awareness that rotation of these varieties is important to maintain these tools' effectiveness long term. There's really only 2 resistance sources available, and there's not any directly in the pipeline that we're going to see soon. So maintaining those is going to be a huge economic advantage to every grower who's able to keep those working well on their farm. Now, we also raise awareness of the other active management opportunities that Horacio listed, and we do this through a network of different state universities across the Midwest and the US, as well as Ontario. And we work with national checkoff and state soybean checkoff organizations. But then we also work with private companies who also have an interest in increasing the awareness of this and increasing active management of soybean cyst nematode. Here's just some examples of that private partnership that we've managed with them. Here's a picture of Horacio at a BASF event where he's able to share the science behind this problem. And then here's Greg Tilka of Iowa at a Syngenta event where we're able to utilize their platforms to get our message out there on effective management of this. So we're an outreach tool. So here's just a little bit of a summary of how we do our outreach. We do a lot of social media over the last several years. If anyone hasn't been there, please go to our website at thescncoalition.com. That's also where the profit checker is housed. So scnprofitchecker.com will get you to that tool. And just a lot of other traditional media outreach as well. The SCN Profit Checker has been extremely popular for anyone who has a soil test result or knows how many nematodes they have. We've had over 90,000 users in the last year and a half of that tool. So over time, we've been able to monitor changes in management. In the 90s, early 90s, a lot of growers weren't really aware of this and didn't know what to do about it, and they really didn't have options for what to do about it. But as tools rolled out, that first generation really used PI 88788 as a resistance source, and it helped alleviate this problem for several years. In the early 2010s is when we noticed that 88788 was becoming less effective, and the SCN Coalition started to build awareness of this. In the last 10 years, we've seen large increases in the number of farmers soil sampling for SCN. We've seen changes in how many have been rotating sources of resistance, and then how many have been using peaking as a resistance source as well. But one finding is just the perception of yield loss to this. With it not being noticeable, many growers don't know how much yield they're losing. So their surveys show that they anticipate or believe they're losing about 5.4 bushels per acre. But our research has shown that there's a lot of growers out there losing a lot more than just 5.4 bushels an acre. And building that awareness is really important to help preventing that yield loss.
Okay, so we're also aware that there are other plant parasitic nematodes that are threatening soybean. And we're also aware that in some regions of the United States, especially the southern states, other nematodes may be more important than soybean cyst nematode in terms of threat that they pose to soybean production. And with that in mind, the SCN coalition is expanding, right? And we do this through different projects. One that was funded by USB, United Soybean Board. And this is to start looking more into these other nematodes, right? Create and develop management guides. So the other important nematodes that affect soybeans, so we have soybean cyst nematode that we have been talking about, but in the southern states, the root knot nematode is the most important one, right? And overall is the second most important soybean plant parasitic nematodes in North America. Lesion nematode as well, very important, and reniform nematode specifically because of their abilities to also infect other crops, right? So that it poses threats to multiple crops. So just as an example of how damaging some of these nematodes can be, the southern root nematode, it's very noticeable, the damage that it can cause both above and below ground. So some of the very characteristic symptoms will be the development of these galls, and really the nematode is embedded in that tissue. We don't see that nematode being attached like the soybean cyst nematode is, but it's a very diagnostic symptoms. We pull those root and their gall, so we can see the abnormal growth of those roots, and that's just an indication that we may have root knot nematode, right? And that clearly show that uptake of water and nutrient is compromised, and we can see that in a field. So in the summer season, we can walk those fields and we can start seeing plants wilting prematurely, and we can suspect that we may have this type of problem. So we wanted to bring all this information in management guides. There was a SCN management guide that was outdated for over a decade and needed update. And that was one of the purpose of this project, to update the SCN management guide with a lot of information for growers, consultants, industry partners and collaborators, and a great resource, right? And in addition to this, create these other three new management guides for the reniform nematode, the lesion nematode, and root knot nematode. And each of the guides are led, of course, by authors and nematologists with a lot of experience on each of the topics.
So management for soybean cyst nematode has really changed over the years. From the 90s, where there was really no tools, PA 88788 did a really effective job for a lot of years. Until the mid 2010s, when in the absence of that full effectiveness of 88788, and while they were waiting for or continuing to develop new resistant varieties, a lot of chemical control options came onto the market as well. So a lot has changed in that time and continues to change. So just going forward, there's some new tools becoming available, and they will change the way we manage this. In addition to those new tools, maybe we'll get new resistant varieties as well, which will serve as a really strong foundation to management. So just some of the new tools we've got from BASF, there's a new tool called Nemosphere, which is a biotech product that's going to be coming out. When is that going to likely come out? Maybe
2028. That's where we're expecting to see that in the market. Again, that's essentially a genetically modified tool. It's the plant expressing a cry protein. It's like a BT, and this will be added to native sources of resistance. So we may have this technology on PI 88788 background or Pekin background, and in addition to multiple herbicide traits that control that growers want to use and are used to implementing, right? New products out there in terms of chemistry technology and chemistry advances that we are seeing. The most recently is the product that Syngenta has launched. Vitrato is the name, Timerium technology, and these are all products that we are evaluating in our different um, trials. So we're constantly working with growers, seeing how well it works, and we're constantly excited to see more tools coming out.
Mhm. So we listed some new technologies, but what we want everyone to keep in mind, just as concluding thoughts here, is the importance of managing this actively through many different mechanisms. None of these are going to solve this problem. If you want to know if you have this, you're going to have to continue to test. And if you want to know if your management is working, you're going to have to continue to test soil, sample your fields. The foundation for any chemical control is always going to be varietal resistance. Make sure if you're going to put a seed treatment out there that it's on a good resistant variety, and make sure that you're managing those resistant varieties appropriately, rotating between different varieties to maintain their effectiveness as long as possible. Continue to rotate to non-host crops. We're just lucky that corn is a non-host crop and that it effectively works to keep those populations low in your rotation. And then lastly, consider using a nematode protectant seed treatment in combination with these other management tools. So I think that's pretty much it for us as far as this update on soybean cyst nematode. If you have any questions about soybean cyst nematode, please visit our website at the sencoalition.com or contact your local state extension representative about this. Several states across the Midwest have free soybean cyst nematode testing programs. So if you've never tested before, reach out to your local extension service and take advantage of that testing.